In these next 3 weeks, we're going to talk about some financial mathematics. So this week, we're going to talk about savings models, and we're going to talk about interest and how interest is earned given certain information. So first, we'll start with a couple definitions. The principal is the initial balance of an account. Simple interest. So right here we have, well, interest is money that's earned after a given time on an account. Simple interest is interest that is paid on the original principal only. So let's look at an example. Example. You deposit $1,000. Through this video, I'm probably going to forget the dollar sign many times. Our money is in dollars. Suppose you deposit $1,000 in an account that pays interest at a rate of 10% annually. And we'll ask two questions. One, how much is in the account after 1 year? Question one. Question two, how much is in the account after 3 years? How much is in the account after 1 year? How much is in the account after 3 years? Well, it earns 10% every year. Let's answer part A first. If you deposit $1,000 in an account, how much is in the account after a year? Well, it's going to be the amount that's there plus the interest. We'll assume you're not withdrawing anything just for this example. It's a savings. You deposit $1,000, so let's find the interest. Let's spell interest correctly. Interest earned. Well, it's $1,000. It earns 10% a year. We're looking here after 1 year. So $1,000 times 10%. For multiplication, we're going to translate the percents into a decimal, which of course we can do by considering it as a number with a decimal point there and dividing it by 100. In other words, moving the decimal place over 2 positions. So 10% is 0.1 as a decimal. Usually when I do these, to check myself, I always write the decimal first, and then I move the decimal place over to the right 2 positions to make sure it's the same percent. I always find that easier, especially with interest rates like some that we'll be seeing maybe on the back of the page I just looked at. But here, 10% in 1 year, so the interest earned is 1,000 times 0.1, which is 100. So the amount in the account, so it's amount in account equals the initial 1,000 plus the 100 earned in interest, which is $1,100. So I'll throw a dollar sign on the answer. What about part B? Well, if you're not told otherwise, you will assume simple interest. So here, this is simple interest. This is interest that is paid on the original principal only. So the fact that after 1 year this is $1,100 means nothing as far as this interest is concerned. This interest just says, given 1 year, we're going to give you $100 because the initial amount was $1,000. So interest in 3 years is 3 times that $100. It's the same for each of the 3 years with simple interest. So after 3 years, you get $300 of interest. So the amount in the account is the initial 1,000 plus the 300 earned in interest, and that makes what, $1,300. So simple interest does not earn interest on the interest, if that makes sense. In other words, this may be $1,100 after 1 year, but that doesn't mean the interest is going to be 10% of that after that year. It's going to be still $100 because simple interest is paid only on the original principal. What about after 20 years? So let's throw a Part C on this. How much is in the account after 20 years? Well, that's similar to the last one we did, Part B. But let's try to do it in one step. So Part C. How much after 20 years? Well, you could do 1,000 plus 100 plus 100 and so on. Let's set it up in one step. Let's call it, what letter does the textbook use? A. A. And let's be a little careful in how we're setting this up. A is the amount you start with, 1,000, plus the interest earned. Plus the interest earned. Well, we know that the interest earned is 10% of 1,000, also known as 100. But then we're going to earn this each year for 20 years. So we have 1,000 plus the interest earned per year times the number of years. And of course, this equals what? 1,000 plus, what is that, 100 times 20? Plus 2,000. So it's $3,000. So we can, actually, before deriving a formula, let's do another example with some different numbers. Might be able to derive a formula now, but let's look at one more example first. So let's change the numbers. Let's leave it at 1,000. That's a nice number. And interest is paid, let's change this annually up, at 5% monthly. That's nice, I think. Suppose you deposit 1,000 and interest is paid 5% monthly. So before we had an annual rate. Here we have a monthly rate. So we're going to earn 5% each month. It's still going to be simple interest. So this 5% per month is going to happen on the original 1,000. And let's actually ask a question. How much is in the account after 2 years? How much is in the account after 2 years? Well, we have a lot of units all over the place. We have different time units. This interest rate is monthly. Let's make these years monthly. You could turn that into an annual rate and deal with it that way. I think it'd be easier to deal with if we just change these years to months. 2 years, 24 months. A unit conversion? 2 years times 24 months per year gives 24 months. So how much is in the account after 24 months? Well, let's find what happens in 1 month. So in 1 month, once we find what happens in 1 month, well, all we have to do is add that on 24 times. So in 1 month, interest earned is what? Well, it's $1,000 times the monthly interest rate, 5%, which is 0.05, and you can see that by, if you move the decimal place over 2 points, then you'd have a 5 with a decimal point, which gives you that whole number, 5. 1,000 divided by 20 is what, 50, I think? Yes, it's 50. So in 1 month, this earns $50. So in 24 months, the interest earned is 24 times 50. Let's write it as 50 times 24 to remain consistent with the previous example. Is 50 times 24, which is what, $1,200. $50 up there also. So in 24 months, the interest earned is that much. So after 24 months, the amount in the account is what? What was it? 1,000 plus 1,200, which gives us $2,200. So that's nice. These interest rates aren't necessarily realistic. They're largely convenient numbers. Some of them we'll deal with will be inconvenient numbers. But we can turn all of this into a formula that computes for us how much we have in an account after a certain amount of time given a certain amount of interest. So let's write that as a formula. So given a principal P and an interest rate R, the interest earned in T time periods is just the product of P, R, and T. And we saw that in those examples, and some of them we did in one step. It was what, 1,000 times 0.1 times 20 in the one we did. So the interest earned in one time period is the principal times the rate, and then in T time periods is the principal times the rate, and then T times, or times T. So that gives us the interest earned. Well, the total amount accumulated in the account is then P, the initial, plus I. And this is for simple interest, is P plus I. And let's simplify this a little, actually. P plus I. What does that equal? Well, I equals PRT. So this equals P plus P. P plus PRT. Well, can that simplify? Well, it can't really simplify that much, but it can factor, because both of these things have a P. So let's pull out a P. You pull out a P from that first thing, you're left with a 1. You pull out a P from the second thing, you're left with an RT. So right there, P times 1 plus RT, where the rate is not a percent, it's a decimal, gives us the amount in the account. In the one computation we did it like this. But notice in the computation we did, that number 1,000 showed up twice. So we could have actually factored that out. But with those numbers, they were easy enough to deal with that I left the 1,000 there. I'll make one remark. Note, what should I say? How should I say it? The time units in R and T must be the same. So R is a rate, so there's a time involved. The time in R and T must be the same. And in the example with the monthly monthly interest earned, we did make sure that the units were the same. We turned everything into months. So let's do an example actually using this formula. I personally like the derivation my guess is most students will probably prefer the formula. So now let's do a couple examples using the simple interest formula. You deposit $10,000 with an interest rate of 6.49% annually. Find the amount in the account after 3 years, after 1 month, after 47 months. And we're going to use this formula. The amount in the account is P times 1 plus RT, and we're going to have to pay attention to our units for R and T, because we have annually for the interest rate, and for B and C we have months. But for part A, we have years and years. So that's okay. So A equals the initial, 10,000 times 1 plus R times T. R is 6.49%, that's 0.0649. And you can see if you move this decimal place over 2 positions, it would be there, giving you the 6.49%. So 1,000 times 1 plus whatever that number is, where did I write it? $11,947. So after 3 years, you earned $1,947 in interest. What about part B? Well, for part B, we're going to have to deal with the units of time. But let's set up our equation anyway, as much as we can. 10,000 times 1 plus, there are times where dealing with the rate is not that rough. With simple interest, I would say it's always easier to deal with the time units on the time and leave the rate as it is. So I'm going to do that. Meaning, I'm going to leave the rate in years and then worry about turning months into years. So 0.0649, and then in part B, we need it to be 1 month. Well, what is 1 month in years? Well, we know unit conversions. We saw them a couple weeks ago. Unit conversions. 1 month, spell month right, times what? The conversion for years and months. How many months in a year? 12. So 1 month is a 12th of a year. So we'll put a 1/12 in there. 10,000 times 1 plus 0.0649 times 1/12 is, so after 1 month, 10,054.08. So in 1 month, $54. That's nice. And what about 47 months? Well, we did the work for B, and that actually does a lot of what we need to do for our unit conversion. I'm going to move the 1 plus over a little. 1 plus. Now we have 47 months. Well, all we have to do for 47 months is change this to a 47, and then we get 47/12ths of a year. So times 47 over 12 equals 12,541 and 92 cents. 0.92. And these answers do make sense because you would expect what happens in 1 month to be less than what happens in 3 years, and that to be less than what happens in 3 and 11/12 years. And these numbers do go, smallest is here, then the next one, then that one. So I think the hardest thing with this formula is being sure the units are in the, being sure the units are the correct units. I mean, sometimes it's easy to go through one of these really quickly and not get the units correct and then get the wrong answer. And we don't want that. But for simple interest, this formula with questions like what we've gone over are what I would like you to know. Now, the next type of interest is compound interest. And that differs from simple interest. So compound interest earns interest on interest. So in that first example, where you earned $100 of interest in a year, but then in the next year you still earned the same $100, well, with compound interest, you will earn on your interest as well. So let's define compound interest formally.